Well, I present a few solutions, but I have solved everything, and you can I provided shell script that you can run everything in the thing, including the conversion from EMF to graphs and back again. So I let it run, and now I discuss some solutions. I start with a second constant transformation. So basically, this says create a complete soup graph consisting of 3 nodes: a greeting message, a greeting, a person, and the greeting message says hello, and the person is TTC participants. And well, the idea of GReTL is that you specify well, a kind of a mapping between source and target. And here as source, I use a set with only the number 1. And so so my mapping will be from number 1 to greeting message, from number 1 to greeting, from number 1 to person, and that the thing I could refer to the new elements if I would like to, but here I don't need. And in between, well, these edges, the long names are because of the EMF import, which somehow concatenates the reference names with the target node names or target class names. Well, basically, this creates the graph. And well, the second thing I want to show is the hello to text query. So for this one, I have 2 solutions. The first solution is the thing that Steffen showed for the transformation judge, which is a transformation that creates some result type vertex with the value set in some attribute, but you wouldn't do that. Usually you would use a simple query. So here we say, well, iterate over all greetings, and for each greeting, get the greeting message and the value of the text attribute, concatenate it with a space, and the greetings connect, or the person connected to the greeting, and its name, and well, then the exclamation mark. And if I run it, well, you see I get hello TTC participants. And well, the next thing, for example, reversing edges. Okay. Well, here I use well, a kind of graph transformation operation, which I quickly hacked for this contest here. So basically, we say this query calculates a set of matches. So basically, I get a set of all edges, and the edge, well, it's a tuple, a set of tuples where the edge is the first component, and then the source and the target, and well, this is the replacement pattern, which just says, well, the edges in between, and now the source and the target are reversed. And the next thing, well, there's another query, which is the query which should calculate all circles of 3 nodes. So basically I say, first I calculate all circles with nodes n1, n2, and 3. They are all not equal, and n1 is connected to n2, n2 to n3, n3 to n1. And well, then I report all their names. And finally, I create a nice sentence. There are x circles, and then I report h circles. And again, if I run that, well, I don't know which example graph it was, but it contains 6 circles, and well, you get it here. Oh, okay, and one last thing, transitive edges, which does not calculate the closure, but instead I first calculate the matches, and then I replace each match I initially found, so I don't produce new matches during the transformation. So, well, and basically it's the same operation where I just create a new edge between the existing nodes I have matched here. Okay, I have 17 seconds. Well, I think I just dance a little bit for you. Yeah, well, I can show you the folder. So indeed, I have solved everything, and for some solutions, I have an alternative version, one as a transformation and one as a query. Well, okay.
Right, okay. So is there anything you want to say in a minute about the review?
I cannot remember. I have answered everything in the forums, but I cannot remember. I think I didn't get critiques about the HelloWorld trace.
Okay.
Well,
did anybody review the GReTL solution and wants to remind us about it?
I think you already improved your solution in several aspects, right? No?
Form?
In my review, I wondered why the constant transformation of just one object was quite a few lines of code.
Yes, right. But I didn't prove it.
Okay.
Well, I just explained the concept behind.
Can you open the one object transformation file?
Yeah, this is two. This one?
Yeah, and I wondered why it is so many lines of code to create just one object.
No, that's three objects and two edges in between.
Okay.
That's a hammer too.
No,
I
then
guess you mean the first.
yeah, the very first one.
Yeah, this one, right? Yeah, this transformation is a little bit special because, usually in GReTL, using the very basic operations I used here, you set attributes isolated from creating nodes or creating edges. So first you create the edge with this operation, and then you refer to the newly created greeting vertex using a function, a partial function mapping from the mapping thing I used here for number 1, and here I provide a value. So, well, it's conceptually a little bit different, but it makes sense when you consider, say, type hierarchies with one abstract superclass which has a name, and in usual transformation language you would duplicate the setting of attributes for every concrete subclass in each rule. And so here you say, well, this attribute and give it a function which defines the value for every element of this abstract type and subtype.
Okay. Then
So
next.
I noticed some problems with dangling edges. You don't support dangling edges in some cases.
You cannot have them.
Yeah, you can.
Well, in this case, the edges are in fact nodes, and then you can have dangling edges which are, well, nodes of type edge.
Yeah.
And yeah, I have a query which calculates exactly that.
Okay. But we have to move to the next presentation.
Sure.